Hi, this is Navin Raj, chemistry lecturer. Please subscribe to my YouTube channel.
Hi, my dear students. Uh, we are going to start our solid state. Before starting that, we want to know about some little basic concept, that is matter. Matter, anything which has mass, it occupies space. Anything which has mass, it occupies space. Matter is classified on two conditions. The two conditions are, number one, normal condition and extreme condition. Normal condition further classified based on states of matter: solids, liquids, gaseous. When come to extreme conditions, it's classified into plasma, Bose-Einstein condensation. Yeah, in this chapter, solid state, we are going to talk about the properties of solids. In this first point, solids have definite shape and value. Why it has definite shape and value? Because in the solids, the constant particles are atom, ion, molecules. These are the constant particles which have closely packed. For that, it has definite shape and value. When we come to second point, solids are rigid. Why it has rigid? Because here also the constant particles are closely packed. When the two particles will be strongly binded. For that, the particles having strong, for that it has rigid. Next, we come to third property, that is solids are nearly incompressible, because solids cannot be compressible by applying the force, because the solids have the closely packed constant particles. Next, last point, solids diffused very slowly compared to liquid and gaseous, because the constant particles in a solids have cannot move easily when compared to liquid and gaseous. In liquid and gaseous, the constant particles are not closely packed, it can move easily, for that it diffuse fastly. When come to solids, the particles cannot move fastly, because the particles are closely packed, it cannot be moved. Okay, please. Yeah, next we are going to study about types of solids. There are the two types, that is crystalline solids and amorphous solids. Now we are going to study about the properties of crystalline solids, then like that only amorphous solids. Okay, first property, before talking the property, we will take a property number one, that is example. For crystalline solids, we take a general example like a diamond. For amorphous, talcum powder. Okay, now if we take a diamond, it's a, if you see the diamonds, it's a regular arrangement of constant particles. When come to amorphous, irregular arrangement of constant particles. Okay, in that, the first property we'll talk about shape. They have definite and regular geometrical form. Why it has definite regular geometrical shape? Because the example, you can see the diamond, it's have the definite shape, regular shape. Okay, when come to amorphous, the powder, while using the daily powder, the talcum powder, they do not have the definite and regular geometrical shape. Next, we're going to talk about its melting point of property of crystalline solids. They are highly fixed. Why it is highly fixed? Because in crystalline, the constant particles are regularly arranged. For example, you see the constant particles are regularly arranged for melting point to break the to break the distance between the two molecules, we need I energy, I heat to convert solids to liquid, that is nothing but melting point. That solids to liquid converting, we apply heat to break between the two constant particles, that is I in crystalline solids. When come to amorphous, the constant particles which are irregular, we can break down. For it is its melting point is low. When come to cleavage property, cleavage are if you cut any solid, it has sharp edges because it's have regular arrangement of constituent particles. When come to amorphous, it is unevenly cleavages. If you cut the amorphous, it never have the sharp edges, it will be different. We can tell that different shape. When come to crystalline, if you cut crystalline, you will get crystal only. When you cut to amorphous, we cannot tell that is amorphous. They are different shape. Okay. Next, the arrangement of constituent particles. In crystalline, the property already I told that it is orderly arranged. Constant particles are orderly arranged. When come to amorphous, it is disordered. Okay. Next point is next property we are going to discuss, that is nature of crystalline. Nature of crystalline is anisotropic. I'm tell that nature isotropy. What is anisotropy? Anisotropy is nothing but we know that the crystals are arranged orderly. You see, crystals are orderly arranged. Is anisotropic means the physical property, if you see, it's having a physical property are different in different directions. Please you know, don't need anisotropic is nothing but physical property different in a different direction. Okay. When come to amorphous, isotropy, the physical property are same in different direction. You see, all I don't want to tell, all I written in this board, you see the property, this is not orderly arranged. For that purpose it will be isotropic. Okay. Next properties, heat of fusion. Heat of fusion is high in crystalline and low in amorphous. First of all, what is heat of fusion? The amount of heat absorbed by a unit mass of a solid at its melting point. Means you see, absorb here, amount of heat absorbed means a solid is taking to melt. That is heat of fusion. Next point is order of arranged of constituent particles. How can you tell that the crystalline is long range order, amorphous is short range order? When come to long range order, you see, already I told you that the particles see, the order is long range order because the order continuity the particles are arranged, for that it is long range order. When come to amorphous, it has short range order.